welcome to our second lecture in our programming language course on Go language. We have our expert here. All right. All right. So yeah, so today we'll talk about structures, we'll talk about methods, we'll talk about generics, on how hard it was to get the generics in Go, also about interfaces, on error handling, of course, as well. And also we'll look at the basic way of handling all of it together, right? Also arrays and slices, of course, like basic data structures, maps. Okay, so again, a reminder that there is a homework 6, which is basically like homework 5, except the only requirement is in Go language. All right, and now we don't have, now the only question that remains, what are we going to do next week, which is our last week. Again, previous years we've done Rust. There was interest in doing something else, because Rust is quite a bit harder, and of course 2 lectures will not do justice to Rust programming language. You could do a whole half semester course on Rust. We could do something with front end, I guess. There was the idea of doing some sort of front end project, perhaps, right? Something like that would be cool. Yeah, something like that, right? Yeah, yeah, something like that, right? So that's a possibility. So this will be, hello there, welcome back, right? So. Yeah, something maybe we'll see, right? So that still remains an open, right? So there will be one more homework again, and the idea is, of course, when the exam time comes, I will want to look at your last 3 or 4 homeworks. Basically, you have to explain, tell me a little bit about how you did your work, basically.
Also, the exam will be just explanation.
Yes.
Okay,
yeah.
Cool.
So.
Do you know the approximate
Dates,
dates?
they might have been somewhere in email, but they might change. I believe it's somewhere end of April, right? Yeah.
It should be.
Yeah, so I'll probably do the same, probably 17th or 24th, probably, I don't know, right? Something like that, right? Yeah, we'll see. Okay, so again, today for the homework 6, you do a CRUD application. Up to you, what you can do the same thing you did before, but you could do something else, right? That'll be more interesting, perhaps. And it's due 7th of April. 7th of April. Okay. Now, so let's continue with Go, and we'll go with Go structs, all right? And more types. We'll see structures, right? Or maybe let's go actually arrays first. Actually, let's do arrays first. Actually, might be more important, right? Check out our basic data structures first before we make our own structures. That might be more useful. And let's do code space again. And it seems, yeah, Go actually comes built into code spaces, so that's kind of nice. And we can use it immediately. Right. But again, Goland, right? Do you use Goland for development or no? What do you use? Go. What do you use? Visual Studio Code?
Yeah.
Okay. Yeah. And which plugin? The standard one, right? Or any?
I don't know.
Don't know.
Well,
whatever the.
I installed the plugin a while ago, but I don't exactly
Right.
which one.
We'll see what we have. Okay, what I was using, again, because there were a couple, right? So again, the full, like the JetBrains Goland, that was, yeah, I think it's called Goland, right?
Yeah.
Yeah. And again, remember, if you are a student, right, even from Latvia, right, you still get it for free, basically, the professional version, right? I guess you're not supposed to use it for production code, I guess. You're supposed to use it for learning, right? But, it's still pretty nice, right? So, but again, it's a little bit heavier than Visual Studio Code. So again, I'll stick with Visual Studio Code because, of course, that's what's available in our code spaces, right? So, virtually, right, where are my repositories? Oh, there we are. I'm lazy. Oh, you don't see anything, right, okay. Okay. You see it. You see it already. Yeah, right. All right. We'll go here. Right. On the code space, and we have our Turbo Palm tree. And let's see what we have here. Hopefully no updates are needed. This is just hopefully. And let's check our extensions now. All right, looks like everything is okay. No, there's two updates for extensions, unfortunately. We'll have to get, yeah. Yeah, Copilot wants to reload. Okay, sure, why not? So of course, arrays. So let's talk while it's loading. Let's talk about arrays in Go. They're just like normal arrays, right? They're fixed size, numbered sequences, right? And usual assignment, we can do assign values, but what we cannot do, we cannot change size for arrays. So what do we use instead? Typically, we use slices. And what are slices? What is slice on an array?
Well, like a part of an array?
Yeah, it's basically a reference to a part of an array, basically, right? So slices are interesting because they are flexible, right? They have capacity, right? We'll see how they work, right? So you can adjust them, change the size of slice, but they technically refer to an array which there's an array underneath, right? So you can expand the slice to the size of the array, maximum size of the capacity, right? So, but it can be a very tiny slice, and of course you can have multiple slices for the same array, of course, right? So the key to remember, of course, with slices is that there's an array underneath, so when you change a slice, data in a slice, you will be changing the data in array, right? So, again, so there's some similarities with Python, tiny some similarities, right? But of course, with Python you make copy, with slice make copies of lists. Here you actually have an array. So let me see what I have as my Go. I have rich language support. This one, Visual Studio. Oh, of course it's Go team at Google, right? So yeah, it's probably that's you're using too, right?
Yeah, I just checked it.
Yeah. So yeah. All right. So that should work. And let's go to our Go projects. And again, you have a hello, you have Tor, right? And let's do again. Let's look at data structure. I'll make a project called data structures. Again, let me see my history. Does it show my history? No, it doesn't show my history, what I did before, unfortunately. And let's make a folder called, I'll call it structures or something like that. Structures, right? And again, it would be a good idea to just actually provide a namespace for it, right, like we did here, right? But I will just skip it for now since I am lazy, right? I'll see if I can just swing it without doing anything extra, basically just build it. So, I'll call it arrays. I'll call it maybe arrays, slices, right? Go, right? Let's explore slices, arrays, and slices in Go language, right? And again, let me turn on. So package main, I'll just call it package main for now, right? Since I'm lazy, right? And we'll call it, because we need, we'll import formatting, right? Since we want to show something, right? And let's declare some arrays. So function main, and let's declare an array, right? It's not going to be any, I'll make it a little bit bigger so you can see this, right? Again, it's pretty simple, right? So, okay, let's declare array of 5 integers, right? Right, so, and it's empty, right? So what's interesting, of course, is that, and of course I need to close this whole thing, right? And let's declare array with values, right? Array 2 or array 1, right? We have 1, 2, 3, 4, 5, right? Array with values. So what do you think is going to happen? Is this empty array, what kind of values will it have? This one here, R. Well, if I'm just declaring it empty, well, yes, it should have zeros, because Go has this.
Usually when I print the empty array, it just prints it as an empty array without it else.
Okay, we'll see. Okay, let's still see.
Really
Okay, well let's take a look. Okay, let's take a look again. So again, Go in many cases. So that's one of the tendencies for Go is, and this is also a critique of Go, right? And it's a good and bad thing. So some say it's a good thing, right? That if you have something, remember if we declare variables, right? They'll have default, will have the null type of value, whatever it is, empty string or zero, right? Whatever it is for the data type. That's a tendency. So it should stay true here. Okay, let me see if I can build it without any mod. Let's see, module file cd go, and what we have arrays. Oh no, I mean, yeah, what do you call structure? Yeah, okay. So go build, and I'll call it Let's see if it builds. It should build, right? And it built. And so I have a binary, right? I do have a binary, and so I will run it. See what happens.
Could you close the on the big screen if you close?
Oh, this thing. Oh, yeah. You can't see the terminal. Sorry. Yeah. All right. Let me move it. All right. So yeah. So we have again. It's probably still about 2 megabytes in size. Again. So one of the strengths of Go, of course, is it's the fast compilation speed, right? Some people are saying, like in some other language, they're doing like even the ID is slower than compiling in Go. So that's one of the reasons you get you get the speed of compiled language, but also you have the speed of development also, because one of the problems is compiled language, of course, that your project takes a long time to compile. So that is not the case with Go. That's one of the things again they really pay attention, right? Because they know again it's nice. You run it and it's quickly you're ready to go, basically ready to go, pun intended, right? So yeah, I was right, right? So 0, 0, 0 and 1, 2, 3, 4, 5, right? And here, so we can access, of course, individual values. We can access and mutate values for Unix. So value 2, right? And let's change it, right? 10, and of course array after mutation, right? So we'll see that which value it will be. It will be the third value, right? This one here, right? That's be normal programming practice, right? So go bell slices, and let's see, can I pipe this thing, right? Can I do, no pipe, but can I do a comma? What is it? Can I do this since I'm lazy? I think you can do this. I forget now. Can I do this? Yeah, I can do that. Okay, yeah, since I want to do one command, build, right? Build and run, right? So the mutated value at index 3 was 3, right? Index 2, which is of course third item. So again, this is just standard programming language practice everywhere, right? So, all right. So array. So let's go to slices. So slice is a Now let's look at some slices. Now let's declare. Now let's talk about a slice. Slice in Go is a dynamic, flexible and dynamic view of an array, right? Right. You can also do make functions well, right? Okay, so let's make a from an array. So array 1. So 1 to 4. So if again I'm not using it, but I'll be using it right now, right? So it's not complaining. The go. So slice, right? So look at the syntax. This looks very familiar, right? It's kind of like Pythonic syntax, right?
Yeah, that's one of my favorite features of Go.
Yeah. So again, it's like I said in other languages. This is. I think it's nice. It's nice. They took this thing because again, remember this is done about 15 years ago when they made this language, right? So let's build it, and it builds. So slice from array. Not surprisingly, look at this here, right? So we include second, third, and fourth, but this is the index 5. Fifth item with the index 4 is not included, right? So again, I was using hash. So again, we take indexes 1 to 3, but not 4, right? Just like Python. Yeah, exactly. You see, it read my word. AI read my speech.
But it returns still the array type.
Excuse me?
It still returns the integer array type.
Yeah.
Slice 1.
Yeah. So slice 1, yeah, of course. So now we can modify, of course. So now, when we modify, say, second value in slice, yeah. So let's take a look. So slice 1, 1, right? So that's was 30 now, right? Slice, print slice, right? So you're not going to be shocked that this is going to be changed, right? Hopefully not, right? I hope not. So I'll build it. And indeed, yes. Okay, 20, right? Right. So simple to use. So yeah, so slices have capacity. Let's check out. Slices have capacity and length, right? Length. So this is one of those things. Length is number what you have currently, right? And capacity is as much as you can, because you're sort of peeking into this array, right? That's the most that you can have in this particular slice. So the thing is, now of course, if I don't remember offhand, what happens if your slice looks in different array? Will it change? I think I think you're allowed to do that, and it will change the capacity. We'll test it, right? Yeah, yeah. So let's take a look. Length and cap functions. Let's see them. Let's see length and capacity of slice 1. Length, right, and capacity. So these are built in, right? So length, we can of course, our Go plugin tells us length of V according to its type, right? So slice, if it's a slice, number of V. Again, of course, length depends on what kind of type you have, right? So strings, of course, how many bytes. Yeah, we didn't, of course. So that's kind of a little bit not so, compared to Python. This is more like C type behavior. You're getting bytes, not Unicode code points, right? So a little bit lower level, right? Number of bytes, not characters, right? That's not going to be the same, right? Even though this, of course, has full support for Unicode code points. Okay, so let's take a look. Let's run it again. Yeah, so length of 3, but that's very interesting. Why is capacity 4? Let's take a look. Can we not go? Why shouldn't be capacity be 5? Right. So how about length of an array? Right. There's no capacity for an array, right? So that's very interesting, actually. Right. So length of array 5. So I thought you could increase it actually to the actual length of maximum, right? Or am I wrong now? I thought there was a way of, so the capacity 4 is a little bit strange here, right? I would expect it to be 5, right? So starting from a first element in the slice. Right. Okay, starting with first element. Okay, so how about we create a slice from beginning, right? For say 2 elements, right? Notice again. So length and capacity, length. So I expect it will be 5. This should be 5. This capacity should be 5. Yeah, because we start from beginning. Right, so a little bit tricky, right? But I thought we could increase this also if we start from second item. We start from second item here, right? So, right. So here we start from beginning. Again, notice the similar. No, it is similar. Index 2, right? Very similar. Yeah. So 0 is hidden. I mean, 0 is implicit. Yeah. 0 is implicit. Okay, let's run it again. So I expect 5, right? And length should be 2, because we only took 2 elements, right? First 2, but capacity should be 5, right? Yeah, it is 5. So the question is now, this is kind of interesting, like, since I don't do Go every day, so how about changing slice 1 to have capacity of 5 as well, right? Slice 1, append 30 and 40. Let's take a look at what's happening here. We are doing mutation, right? So to the end of so this should give us an error, right? Right. But very interesting. If it does not, a new underlying array will be allocated, right? Append turns an updated slice, right? So but this is interesting, actually, right? Destination is a slice to accommodate the new elements, right? So this, if there's no room, there's going to be new underlying array. But how are we going to get it out? That's very interesting, actually, here in this case, right? So.
It doesn't create a new instance of array.
So let's take a look. It should be now 5. It should be 6 now, right? So how about print? Let's print or underlaying. Okay, let's take a look. This will be interesting to see. Okay, so, all right, yeah, very interesting actually now. So we added the 30, 40, right? So it actually we have a new array now, right? There's a new underlying array. Let's get it. Let's access the underlying. Yeah. So slice one. Let's take a look if this actually works, right? I'm not 100% sure this will work. Yeah, it doesn't change, you see. So array does not change because we have a new underlying array. So I don't know actually if there's a way to get it once. So that's a very interesting point actually. So slices actually, they're not fixed actually. So if you look about this append function, right, that it appends to the end of the slice, but it changes you. Very interesting, right? So basically, if there's no room, right, then a new underlying array will be allocated. So let's try something else, right? We get the length of slice 2. So what happens? Let's append 2 elements to slice 2. Right, 50, 60. How about array? Length and capacity. Come on, I'm lazy. Okay. And again, don't look at the comment. This might be wrong because AI is not that smart. All right, don't look at this. All right, so very tricky. It could be a little bit tricky. Yeah. So length, capacity is 4. So this is what. Okay, so now I expect. Now let's see the underlying array, right? So I expect that this will be 50 and this will be 60, right? Because that's how the underlying slice 2 is actually. So very tricky, a little bit tricky, not a little bit tricky. Yeah, it is. Okay. All right. So that makes sense. All right. So if we have room, right, or original array, that will be mutated. However, if there's no more room, it's not an error. I will talk about errors also in a moment. But there is sort of mystical array. So what's interesting, of course, is the capacity. Why is it 8? Well, it's probably using this algorithm, right? Probably some sort of logarithmic algorithm where it does not, if you change capacity, it would be stupid to change capacity, reallocate by one, because it's a lot of extra work moving. So it does underneath, right? You reallocate in bigger chunks, expecting, you keep increasing the size. So if I had let's test this. This is my theory. If I have I want to make me a bigger array, and I will adjust the size a little bit more. Let's see what happens, right? So let's make an array of 1,000,000 values, right? Let's create an array of 1,000,000 items, 1,000,000 elements, right? Okay, nice, right? So zeros, right? Let's create slice. Not all, but let's do what? 999? 999. Okay, right? So.
Does it go more in the scientific notation?
Yeah, I think this is supported. I'm pretty sure it is. Let's take a look. Yeah, I used it. I don't know, a long time ago. I think this is correct, right? So basically, we say okay. So 1,000,000. So 1e6 is 1,000,000, right? Right. Okay. Now of course, on the right. That sounds correct. But length should be 999, right? Length should be 99, right? Right? It makes sense. Okay, and of course, length of original array, right? And of course, right, we would know, of course. Let's print the last. Let's print last 5 elements of slice 3, right? So we can do this, right? The slice. So of course we can slice the other. We can slice the slice, right? So this should work. Okay. Now let's compile this whole thing and run it. Yeah. So of course it's all zeros, right? There was a way of doing range. Of course we could do, of course, regular for loops, right? To create or initialize with null 999s. Let's populate this, right? Let's populate it. Let's populate the array with values from 0 to 999,999,999. Right. Look at this here, right? So less than 1,000,000. Let's see this late. Of course, I could have used one. Right. Okay. Right. All right. Let's take a look now. So hopefully this code is pretty simple, right? So everything looks okay. Now let's append three values. Now let's append three values to our slice 3. So this I expect, this is experiment, right? Capacity, yeah. Well, I don't know if AI is completely correct. We'll see. But yeah, this would not be surprising. I was thinking maybe 1.6 million, but 2 million would be not surprising because there's a tendency to just double it. So the idea is next time, if you're going over 2 million, it will be 4 million, right? So idea is the old saying that your appetite grows as you're eating, right? So, right? So you eat, that means you probably need more, right? So let's take so original array, of course, will be still stay at million, right? All right. So again, yeah, of course, last 3 sides, of course. Oh yeah, is that last three? I guess, yeah, last 5. Let's see. Does it do math correctly? No, it's not. Doesn't do it math correctly. Now I don't know if was there negative indexing. I don't think there was, or was there?
I think there was.
Okay, let's try it. This legal? No. Must not be negative. I really want to do this, right? Really want to do this. Yeah. So there was maybe something else. Yeah. So.
There was a way.
Well, we could do, of course, length slice 3 minus, the standard, right? Minus, yeah, that works, right? This is what you do in most languages, right? Without slicing, right? It'd be so nice to get rid of this, right? Okay.
That's AI.
Yeah. See, AI would have suggested me this, right? I would expect it, right? Sadly, I'll say there is no negative. Yeah. Okay. Well, not sure. It might be, maybe there's a recommendation. You can maybe look up at this, right? So let's do this. Right. So, okay. Very interesting. You see, AI lied to me. I was right, actually. Look at this weird thing. The capacity is not 2 million. It's actually 1.2 million. So it's using some sort of multiplier, but it's not exactly double size, right? Again, they've chosen sort of like the middle road approach. So it's actually. So we'll see this in this particular version, right? What version we have? Go version. Right, go version. Sorry, like this. Yeah. 1.23. There's a 1.25s coming out, right? It's already out, right? Capacity is actually 1, 2. What was it? Number? It was correct. Not 2 million. Go version. Oh, come on! I had a right here. Yeah. All right. So that's kind of interesting to know. All right. Okay. Cool. I think kind of cool. Now, what else do we want? So, what we didn't appending, copying. So we can copy slice. Right. So let's copy a slice. Right. So this will create. It should copy. Right. So if you want to copy slices, right? Let's copy a slice. Right. Meaning the chain. Underlying, let's copy as well. So slice so this would be, of course, length of slice, right? On slice, right? On this one here, right? From source. So what we make it. So we make an empty one, right? We initialize the length and then we copy, right? The question is, of course, source and destination may overlap, by the way. We can copy over, by the way, right? We can copy from slice to slice, right? So let's see the length and capacity of slice, right? So this is, right? Length should be, capacity should be something like 1.2 something, something like 1.2 million, something. Okay, I like it, right? And it should be pretty fast, right? And let's modify slice 4, right? All right, so let's double check if everything works. No errors. Everything works as expected, right? So we copied 1,000,008 items, no problem. Quick memory, right? No problem. how much memory we have here. Do we have HTOP here? Yeah, we do. We have 2 cores and we have like 8 gigs of memory and 4 gigs free. Not too bad, not too bad. All right. So, any questions on slices so far? Right? Copied, right? So slice is a reference basically, right? So most of your code will be using slices. If you're writing Go, right? You use mostly slices, right? You don't really usually, the arrays are used less, you know. So in conclusion for this part,
So I never think about
you don't,
using slices. I usually treat them as regular arrays.
yeah, you don't, yeah, so that's the beauty of it, right? You don't have to think about it really under, I'll show you a little bit what's happening underneath.
I actually didn't know that the
Yeah.
slices have
Yeah.
the capacity
Yeah.
parameter. I thought that append just creates a new.
Yeah.
new
So it's interesting, but the thing is, what's really weird is, of course I know about capacity, but the fact is that append, if you read about it, that it changes the array what's underneath, meaning possibly, right?
Yeah.
If there's original, if you have space in the original array, it will modify that, but at some moment, once you go over the original, it will start modifying this new array, which you don't even see, right? So it'll be interesting to see if you can actually get to that array, the new array, which is, you know, the underlying, right? There probably should be, I'll do, how to get, how to get the reference to array that lies underneath the slice, right? Yeah, let's go get slice from slice. That's basic, right? So, right. So that will be something interesting to explore. Okay, let me commit this. Let me array slices. We want. We have go, untracked, and yeah, this is we want. Oh, yeah, this one here. This one we don't want to add the git ignore, I guess. And this one we want to commit, right? So added slices and arrays example. Okay, let's take a short break. Let's continue at 12 o'clock. So pretty easy. I said Go is easy. Yeah. I mean, of course there's some ugly things underneath, but you don't really have to think about them, right? You can just use it. That's what I like.